Okay, so we're going to find the general solution of this differential equation. And so the main technique is to separate the variables. So put the x variables to one side and the y variables to the other side. And then we can integrate and try to isolate y by itself. Or we'll isolate y. So we're going to multiply both sides by dx because we want the dx to be in the numerator. Since the dy is already in the numerator on the left, we're going to keep it on the left. Then we're going to divide by y, and then divide by x squared plus 4. Let's break it up in 2 steps. So let's first multiply both sides by dx, and then we're going to divide by y. So we're going to have on the left side x squared plus 4 over y times dy is equal to x dx. Then we're going to divide by the x squared plus 4. And so on the left, we'll have 1 over y times dy is equal to x over x squared plus 4 times dx. All right. Okay, so now we have the y's on the left and the x variable on the right. So we can go and set up our integrals. We're going to integrate. Let's put this in. So we're going to look at integral. Okay, so the right side or the left side is simply going to be equal to the natural log of the absolute value of y. So let's go ahead. Let's write that. Now we're not going to add the constant here because we're gonna have a constant on both integrals, so we just want to have one, so we don't have to because if you have a constant on both sides, it's just like having one constant. It's like having another constant equal to those two constants combined. So there's no need to write more than one, so we'll just write it later. Now for the right side, to integrate this, we're gonna use u substitution. So we're gonna make the u equal to x squared plus 4. And then du will be 2x dx. And we have an x dx, so we're going to divide by 2, so we'll have 1/2 du equal to x dx. And so then we're going to rewrite the right side as the integral of 1/2 times 1 over u du. Okay, so integrating this, the natural log of y will be equal to 1/2 times the natural log of the absolute value of u. And let's just go ahead and rewrite u as x squared plus 4. So we don't have to take another step. And we're going to add our constant here, so plus c. Okay, so now we're going to raise each side we're going to have e raised to each side of each side of the equation. So we're going to have e raised to the natural log of y, and for the right side, it'll be e raised to this whole quantity. So e raised to 1/2 times the natural log of x squared plus 4. And actually, let's do this before we do that. Let's rewrite this as, so we know that x squared is a positive number because any number squared will be positive. So a positive number plus a positive number will be a positive number, so we don't need like the absolute value symbols anymore. So we can just write the natural log of x squared plus 4 there. Natural log plus 4. And we're going to move that coefficient, or this coefficient, as an exponent. So we like the natural log of x squared plus 4 to the 1/2 plus c. And we'll rewrite this side as the natural log of the square root of x squared plus 4. We'll do that here. Just it's usually more formal. You'll see textbook answers in this form, so let's change it here now. So then, going back, natural log of the absolute value of y. So now let's go e raised to this is equal to e raised to that. So e raised to the natural log of the absolute value of y is equal to e raised to the natural log of the square root of x squared plus 4 plus c. And we can rewrite this as, remember, e raised to any natural log is they're just going to equal whatever that quantity is, because they both natural log is by definition of the base e. So the left side will just be equal to the natural or the absolute value of y, absolute value of y. And we're going to rewrite this as e to the natural log of the square root of x squared plus 4 times e to the c. The property of exponents, that when they have the same base e, you just add the exponents. So that's we're just kind of going backwards from that. Now, we do that because this can be seen as just like a coefficient. So let's do this first. Let's get rid of this absolute value symbol. So we'll have y is equal to e. Let's move this as in front, e to the c. But since we're taking away the absolute value symbol, we'll have plus minus e to the c times e to the natural log of the square root of x squared plus 4. And let's recognize that e to the c, that's just some number. That's another constant, because e is, like about 2.71-ish, so it's some number, and c is some other number. So we just let e to the c equal a. So then this can be written as just y equals a times e to the natural log of the square root of x plus 4. So this will be our general solution. Now, when working with differential equations, it's usually a good idea to check. That's a good part about this, is you can check to see that you got the correct answer, especially you want to do that if you have extra time on a test to make sure you're getting all the problems correctly. So we basically are just going to find the derivative of this, substitute it into here, and rewrite the y's as this, and see that it matches up. So let's go ahead, let's check this. This is also going to reinforce that we know what we're doing here. So the derivative of this will just be, remember we're going to use the property of exponents. And actually, what I should do, we should rewrite our general solution without that exponent. It'll actually make it easier to differentiate. And we, again, e raised to the natural log. These can, you can think of it as canceling each other out, because natural log by definition has a base of e. So then this will just be equal to the square root of x squared plus 4. So then we can rewrite our general solution as y being equal to a times the square root of x squared plus 4. There we go. So that'll be much more easier to work with. So let's take the derivative of this. So we're out dy dt. A is just going to be our coefficient. Chain rule, remember that's just x squared plus 4 to the 1/2 power. So we're going to have 1/2 times x squared plus 4 to the negative 1/2 times the derivative of the inside, which will just be 2x. These 2's will cancel, and we'll just have a over a times ax over the square root of x squared plus 4. So we'll have like ax over the square root of x squared plus 4 as our derivative. And so we'll just substitute this into our dy dx, and then substitute this, our y equation, for y here. And we can kind of already see that it's going to work. So let's just do it though. So x squared plus 4. Let me zoom out so we can see efficiently. So x squared plus 4 times this times ax. That's going to be over the square root of x squared plus 4 equal to x times y. So x times a times the square root of x squared plus 4. And you can pretty much see that it's gonna work out, because remember this is just x squared plus 4 to the 1/2 power. So then this is to the 1 power. So on the left side, we'll get that that's just going to be x squared plus 4 to the 1/2 power on top, or just the square root of x squared plus 4 times that ax. Let's just do that times ax. It's a weird way of writing it. I don't know why I wrote it that way. It's equal to ax times the square root of x squared plus 4. So it all works out, so we're good. So always check whenever you can, because it's always good to make sure that you get the correct answer. And so we're good.